Hi again, it's Miss Marion. Let's go ahead and turn to page 120 in the back. Let's go ahead and find our I can statements. We have two of them for today. I can apply a sequence of transformations to one figure to get a similar figure, and I can use a sequence of transformations to explain why two figures are similar. So we're going to talk about similar stuff today. Go ahead and write yourself a sentence and how you feel about those. Give yourself a number, numbers 1 through 4. So 1, I don't remember. 2, I kind of remember. 3, I remember, but don't ask me to teach it. And then 4, I do remember it, and I can teach it to my friends. So go ahead and do that. To start out for today, let's go ahead and turn to page 59. That is in lesson 6 is what we're looking at. And go ahead and answer the question. Use what you know about operations and their properties to write 3 expressions equivalent to the expression known. And so the properties are things that you learned last year. If you don't remember, that's fine. But go ahead and try to see how you can kind of rewrite this to look like something different, but it's exactly the same. So go ahead and pause. Go and do that right now. So this is the answers that you could have gotten. So we have the commutative property. We're kind of switch places. Distributive property, no, hippity hoppity, distributive property. Inverse operations, and then associative property. And so you can kind of see how they're rewritten a different way every single time. But if we actually go ahead and do the order of operation and do these, they'll get exactly the same answer. And so these are the different type of properties. Just getting our brains going for today. And if you didn't know it, go ahead and pause right now and write down 3 of those in your workbook on page 49. So lately, we've been talking about how one figure can be a scale copy of another. So we're talking about dilations, and we've been playing with those. And this kind of relationship can kind of go in both directions. So if I had, let's per se, a triangle DEF is a scale copy of triangle ABC with a scale factor of 2. I can kind of say it that way, and then I can kind of say it backwards. I can say triangle ABC is a scale copy of triangle DEF with a scale factor of 1/2. So see how those kind of are inverses or backwards of each other if you kind of look at it that way. And then we've also learned that this is through dilation. Well, we are actually going to add another vocabulary word for today. We're going to talk about something being similar. So remember how we have exactly the same triangle and one's bigger and then one's smaller. That is what is considered similar. This is not in your workbook, but it's going to go ahead and get us kind of thinking, and we're going to be doing this ourselves in a second. So I have these 2 figures, and it says identify a sequence of transformations, which are rotations, reflections, and dilations that show 2 figures are similar. So how it shows like the blue one is smaller than the green one. If we do an operation, we can go ahead and do that. As you notice, I went ahead and answered this. It said one method could be we could dilate using D as a center point with a scale factor of 2. And you're like, okay, Miss Marion, how did you find the scale factor of 2? And what I did is I actually looked at the distance between these 2. So this is 3. And then the distance between H and F, which is 6. So 3 times 2 is 6. So that's kind of how I got this scale factor kind of thing. And then I'm going to translate D, and I'm going to take D, so D, and we're going to move it over to H, so it kind of sits on top of H. I can rotate 90 degrees clockwise, so to the right, using H as my center point, and then I can reflect the line, kind of reflect it to make it so it matches itself. So this is a sequence of transformations. I can go ahead and make it similar. The part that makes it similar, so last unit we were talking about a rigid transformation makes them exactly the same, which is congruent. The part that makes it so that it is similar is we're talking about a dilation. So when we have dilations come in, that means we're talking about things that are bigger and then smaller. And so that's what we're going to kind of learn for today. So go ahead and turn to page 50. This is number 1. So we have these 2 triangles. It says triangle ECG and triangle LME are similar. Find a sequence of rotation, reflection, and dilations that show this. So you're going to kind of prove it, and you're going to go work with it. So go ahead and pause right now and answer this question. And again, you're going to have more than one. And I will tell you for sure, you're going to have some type of dilation in there too. Okay? So you're going to have more than one transformation to go ahead and make this true, and then dilation is going to be part of that. So go ahead and pause right now and find that sequence. So you can actually do the sequences many different ways. This is how I kind of looked at it. So I said translate L from triangle LME, so that smaller triangle, move it up so it sits on E, and then I'm going to dilate that smaller triangle by 2 to make it bigger, just like the bigger one. So again, I was looking at like the distance on the bottom from M to L is 2, from G to E is 4. So I can say 2 times 2 will equal that 4. So that's how I figured out a scale factor of 2. And there's many different ways. You can actually do this out of order if you wanted to, but this is kind of how I went ahead and looked at it. Let's look at page 51. And so we have hexagon A, B, C, D, E, F, and hexagon H, G, L, K, J, I are similar. Again, find a sequence of translations, rotation, reflection, and dilation that shows this. So go ahead and pause this for a second. Figure out a way that you can go ahead and make these two the same. And again, because they are similar, we're going to have some type of dilation in there, and it's going to be a sequence. You're going to have more than one step to go ahead and show that either the bigger hexagon is the same as the smaller, or the smaller hexagon is the same as the bigger. So go ahead and pause right now and figure out that sequence of transformations. All right, let's see what if you got is the same as kind of what I got. So I have reflect hexagon A, B, C, D, E, F, using the line that contains AF, translate F to I, and then dilate using I as the center point with a scale of factor of 3. And so what I did to figure out the scale factor is I went ahead and measured from D to E, and then I measured from K to J, and saw that it was multiplied by 3 to go ahead and figure that scale factor of 3. And you can actually take your trace paper and you can actually do this on with your trace paper as far as the reflection and then translating it. And so it will actually help out as far as doing part of that, and then the dilation. You can go ahead and do it through measurement and figuring out the scale factor. So go ahead and turn to page 52, and it's actually 52 to 53. And so what we're going to do is sketch figures similar to figure A that use only the transformations listed to show a similarity. So we have numbers 1, 2, 3, and 4. And I'm just going to go ahead and read through those. So number 1, a translation and a reflection. Label your sketch figure B, and you don't have to pause to make sure it's correct. And number 2, a reflection and a dilation with scale factor greater than 1. Label your sketch figure C. A rotation and reflection. Label your sketch figure D. And then a dilation with scale factor less than 1. And a translation, label your sketch F. So what I want you to do is I want you to pause here and actually work through all of those. Many of my students have done it before, where they actually just do the picture on page 52, but they're following the directions between 52 and 53. And so if you put all the picture just around that figure A, that is totally fine. But what I want you to do is go ahead and work through that. So grab your scratch paper, because you're going to be doing that kind of stuff and making things bigger and smaller and rotating and reflecting and translating. Okay, so go ahead and pause right now and go ahead and do that. So after doing numbers 1, 2, 3, and 4, here is my picture. And if you needed to put some of the picture actually on the bottom page of 53, that worked also. But this is kind of what I got as far as the translation and a reflection for number 1, a reflection and dilation for number 2, a rotation and reflection for number 3, and a dilation with scale factor less than 1, and a translation for number 4. And so this is the picture that I went ahead and got. So let's go ahead and let's talk about what does it mean for two figures to be similar. So think about it. And so pause for a second and think. So what does it mean that two figures are similar to me? Well, two figures are similar if one figure can be transformed into the other by a sequence of translation, rotation, reflection, and dilation. So similar is where you're making it bigger and smaller. It's a scale copy. Those kind of things as far as being a scale factor. We're using a scale factor to use it to make it so that it is similar. So go ahead and turn to page 55, and on page 55 there is that glossary term, and then there's an area for similar. Go ahead and write down your definition in your words, what similar actually means. Now if you want to copy mine down, that's fine. This is mathematical, it's kind of hard to understand, but go ahead and pause right now and write down your definition for similar on page 55 in the glossary term. So this is our lesson for today. Go ahead and go back to page 120 and read the I can statements again. I can apply a sequence of transformations to one figure to get to a similar figure, and I can use a sequence of transformations to explain why the two figures are similar. Go ahead and write yourself a second sentence, how you feel about after this lesson. Give yourself a number, numbers 1 through 4. So 1, I don't remember. 2, I kind of remember it. 2, I kind of got it. 3, I did get it, but then 4, I got it, and I can also teach it to my friend. So after you've written your sentence and your number for the I can statement, we are doing practice problems, so make sure you go ahead and do that. Also, on the Canvas page for lesson 6, there are applets in there that you can actually do the same activities in there, and you can do it on the computer, and it's actually kind of fun. If you wanted to go ahead and use that also, you can go ahead and do that also. So have a good day, and make sure you do your practice problems.